Okie dokie, we're going to get started here on graphing quadratic inequalities. And in graphing quadratic inequalities, we are going to use a lot of concepts that you have used in the past to do this. I don't think this is anything new. I'm just showing you how to put together a lot of the concepts that you've already know how to do, and you're putting them together in graphing quadratic inequalities. There are going to be about 4 steps to graphing quadratic inequalities. A quadratic inequality is going to have, either a greater than, possibly a less than, or greater than or equal to, less than or equal to symbol there. But what you do is you graph the parabola y equals ax squared plus bx plus c. You graph that parabola. And after graphing that, you determine whether it's dashed or if it's solid. And after you've made that, you pick a test point to see if it is the solution. And if it is the solution, then you shade the part that the point is in. And if it is not the solution, then you shade the part that the point is not in. And this is all stuff you've done before. You've done it with linear inequalities rather than quadratic inequalities. So let's go ahead and get started here. If it's asking you to graph this quadratic inequality, y is greater than x squared minus 2x minus 3. Okay, so what are we going to do here? Well, remember, we should think about graphing the quadratic inequality that says y is equal to that. So therefore, if it's equal to, a is going to be 1, b is negative 2, and c is negative 3. Okay. Let's go ahead and find the vertex. X is equal to negative b, negative 2, over top of 2 times a. And we work this out. A negative 2 is a positive 2. 2 times 1 on the bottom is 2, and 2 over 2 is 1. Now, once we know what x is equal to, we plug it back into this equation for x. And once we plug it into that equation for x, we can solve for y. So y is equal to 1 squared. We're substituting n for x. And so this is what we have. So work this out. And so y is equal to negative 4. And so our vertex should be 1, negative 4. 1, negative 4 is the vertex. And we plot that point. So we have the vertex. And by looking at the value of a, we know the value of a is positive, so the graph is going to open up. And we know the y-intercept is negative 3, letter C, negative 3. So if we look, I'm going to go ahead and plot the points. This is where you should be making an XY table with 5 points and putting 1, negative 4 in there. 1, negative 4 goes in there. So you go ahead and figure out what the values are and then plot those points. All right, so now that we have our points, we're going to be looking at the equation up here. Y is greater than, is that going to be a solid or a dashed line? Greater than, dashed. So let's go ahead and make it dashed. Make it dashed. And now let's pick a point, pick a test point. I'm going to choose 0, 0 because it is not on the parabola. And so let's pick that test point and go ahead and plug it in. So y is greater than, but remember, if we're picking the point 0, 0, the y value is going to be 0. So 0 is greater than 0 squared, minus 2 times 0, minus 3, and we know those are just 0, so 0 greater than negative 3. Is 0 greater than negative 3? Yes, it is. So we shade inside. So we're going to shade inside this parabola. And so there's your answer. There is your graph to this quadratic inequality. Now the thing is, if we pick any point, what we're actually doing here is we can pick any point. This point is 1, 2, 3, 4. This point is 1, 5. You pick the point 1, 5 and plug it in for x, plug 1 in and plug 5 in for y, and work that out. You're going to get a true inequality. That inequality is going to be true. So that's just one of the points. But if you pick every single one of these points and keep plugging them in for x and plug them in for y, then you're still going to make that inequality true. And that's what you're trying to do. You're trying to find all the points that'll make the inequality that you started out with true. And that's what you've done by shading that. That's what you've done. Let's go ahead and look at this next example here. Same thing. Let's see if you can go ahead and at least find the vertex and find the 5 points needed to graph it. Actually, you can go ahead and graph it because look at the inequality. It's less than or equal to, so we know it's a solid line. So go ahead and graph the parabola there, and then I'll help you out and determine which side of the parabola you will be shading, and then we'll go from there. Let's see. A is 1, B is negative 6, and C is 5. So let's plug in and find the vertex. X is equal to negative B over top of 2A. And we work this out. X is equal to 3. So the y value, let's plug 3 into the equation, or I'm sorry, it's an inequality. We're going to plug it into the equation y equals x squared minus 6x plus 5. Let's go ahead and do that. So we plug 3 in for x. And solve it out. You get negative 4. Y is equal to negative 4. So 3, negative 4 is going to be the vertex. If we look at the value of A, the value of A is positive, so we know it opens up, and that is your y-intercept of 5. You go ahead and make your table and fill in your table. Actually, you probably already have done this because you've paused the video. So I'm going to go ahead and plot the points, and you can check to make sure that these points match the points on yours. And you should have something like this. And it was a solid line because it said or equal to. So let's pick a point. Let's pick that point 0, 0 and plug it into the inequality. So y is 0. Is that less than 0 squared minus 6 times 0 plus 5? So we get 0 is less than or equal to 5. Is that true? 0 less than or equal to 5, that is true. So therefore this point 0, 0 that we have here, that point 0, 0 must be a solution to the inequality. And so we will be shading all these outside. All these points outside. And we even shade them over here. And so the solutions are everything that is outside of that parabola. It's not going to be on the inside, it's going to be on the outside of it. This next example here, let's see if you can go ahead and get this one graphed. Remember, this is supposed to be ax squared plus bx plus c. And there, we have an x squared term and we have a c term, but we do not have a b term. We don't have an x term to figure out what b is. And we know that if there's no x term there, that b is going to be 0 in front of it. And so a is 1, b is 0, and c is -4. And so from here, we can go ahead and calculate the vertex and get this graphed. X is equal to -b, which is -0, over top of 2a, which is 2. So x is 0. So if x is 0, y must be 0 squared minus 4, which is -4. Plug that back into the original problem. Right in there. Okay. So if x is 0, y is -4. Left and right 0, -4, 1, 2, 3, 4. Has our vertex always been -4? Well, I guess it has. The vertex will not, the y value for the vertex right here will not always be -4. In the examples I've given you, somehow it just ended up that way so far. So the y value doesn't always have to be -4. Just heads up there. You go ahead and make your table and find the 5 points to graph this. I'm going to go ahead and plot the points in here for you. You need to check to make sure that your values match my values. Okay, we're good to go there. Now we need to determine whether it's a solid or a dashed line, and it looks like it's going to be a dashed line. And we need to figure, do we shade inside or outside? So let's pick that point 0, 0. 0 greater than 0 squared minus 4. 0 greater than -4. Is that true? 0 is greater than -4. So therefore the point we picked, 0, 0, must be a solution. So we shade everything inside the line, or inside the parabola. Inside the quadratic function is going to be shaded, and this is what we have. And that is the solution to the graph of y is greater than x squared minus 4. And one last example here. You go ahead and graph this one, do the shading, and see if your answer matches my answer when you're finished. So for the x value of the vertex, it's going to be -b over top of 2a, which is 2 times -2. We know negative divided by negative is a positive, so we have a positive 3/2. So let's go ahead and plug this into the y. Y is equal to -2 times 3/2 squared plus 6 times 3/2 plus 3. So we know 3 over 2 squared is going to give us 9 over 4. It's 9 over 4. And then we multiply that by negative 2 over 1, which is going to give us a, cross that off becomes a 1, cross that off becomes a 2, which is going to give us 9 halves, negative 9 halves. I crossed off the 2 and the 4, and I reduced those before I multiplied. You could just multiply straight across and then reduce if you wanted. So now let's look at 6 over 1 times 3 over 2, which is going to give us 18 over 2, which is going to give us a positive 18 over 2. And you might say, hey, that's 9, but I don't want to change that to a 9 because I'm going to need common denominators to combine those fractions. And then if we look at the 3 is 3 over 1. It needs to have a denominator of 2. So I have to multiply the 1 by 2 to get 2. So then I got to multiply the 3 by 2 to get 6. And so this is where we're at. So now if we look here, we have negative 9 plus 18 is positive 9. And then plus 6 is going to be 15. 15 over 2. And so our vertex is, the x value is 3 over 2, the y value 15 over 2. And we know that 3 over 2 is 1 and 1/2, and 15 over 2 is 7 and 1/2. So we can go ahead and plot that. 1 and 1/2 is like here, 7 and 1/2, 1, 2, 3, 4, 5, 6, 7. So there's 7, so right there is our vertex. 1 and a half, 7 and a half. So we know the graph opens down because A is negative. Let me erase some of this vertex work. If you need this, go ahead, and if you need the vertex work, pause it. Let's go ahead and make our table, our XY table. And we look at this. We put our vertex here in the middle. And now let's go ahead and find some other values. I know that, like I said, this is 1 and a half. So if I go down a half, that takes me to 1. And then from 1, I go down another, I'm going to go down a whole 1 to 0. Well, if I went down a half to get here, I have to go up 1/2 to get here. So 1 and 1/2 plus a half is 2. Let's see. And then from here to here, if I went down 1, I should go up 1. And that would be a 3. So this is where we're at. You go ahead and plug in your values and work that out and see what you get. And it should look something like that. Okay, so now we're going to be graphing this. And let's look, solid or dashed. Sorry for the pause there. I was checking my calculations to make sure that I was right. So is it going to be a solid or a dashed line there? It looks like it's going to be a solid. So let's go ahead and go and put our solid line in. And from here, we need to pick a test point. I don't like 0, 0 because it's too close to the parabola. If we look, 0, 0 looks pretty close there to the parabola. So let's Let's still pick a number. Let's pick, what do we want to pick? Let's pick 1, 1. 1, 1 is the one we're going to choose. And let's plug that into the inequality. So y is 1 greater than negative 2 times 1 plus 6 times 1 plus 3. And let's work this out. So is 1 greater than or equal to 7? I don't think 1 is greater than or equal to 7. I'm going to have to say no on that one. So therefore, that point is not a solution. So if 1, 1 is inside the parabola and it's not a solution, so the solutions would then be outside. The solution is outside. And so there we have it. There's the graph of that quadratic inequality. Well, that's all we have for this video, so appreciate you stopping by. If you have any questions, ask me the next time you see me. Have a good evening. Have a good morning. Have a good afternoon. You have a good whatever time of the day it is. Thank you. Have a good day.